Kia ora, it's Mike Atkinson. This presentation is looking at place protection, or sometimes called natural protection, and it's looking at four main types of place protection: bollards, hexes, wires, and cams. Now, one of the key features when you're placing your own gear and not clipping bolts is to make sure that the rock around the placement is solid. So you need to carefully examine the rock, and it must be solid before you place anything into that piece of rock. So test it. The first type of place protection we'll look at are bollards. Bollards is a generic term for we're using it as a generic term for boulders and trees. Now, some general principles or key principles with any bollard is the bigger there is, the better. So whether it's a bigger rock or a bigger tree, the bigger it is, the better. Always test to see if it moves or vibrates by trying to lift it from different angles and kicking it and seeing if it vibrates or not. If you have placing a sling or rope around a bollard, make sure you're keeping it low to the ground so it doesn't create a lever. So keep it low or to the base of it. And ideally, you can thread it through a pinch at the back, especially with a bollard. I'll talk more about that later. This example here of a bollard shows that it's got a sling around it, and you can see the climber there on the other side, on the cliff side. Now, what's really good about this one is that it's a nice big boulder, and you can see that it's actually wedged between, it's got two other boulders that it's leaning up against it. So what they've done here is they thread the sling under both of the pinches. So you can see it's pinching there against the two rock bollards and pinching there. So if you thread it underneath, there's absolutely no way that the sling can roll or come off the top of it. So ideally, when you're looking for a bollard placement on a boulder, then you can try and keep it low and keeping it so that it's stopping from coming off the top. Now, sling or tape is flat, so it sits snugly against the rock, whereas a rope, being round, is more prone to rolling. So that's why slings are quite good for going around bollards. Some of the key features when you're looking at using a tree as an anchor or a bollard is to make sure that it's well rooted into the ground. So give it a push from different directions, see what the tree does, and does the ground move? Is it into shallow soil, or are the roots deeply seated into the soil? Also make sure the bigger diameter, so the width of the tree is really important. So obviously the wider the diameter, the bigger the diameter, the better. This example here is a bollard of a very poorly constructed anchor. One major thing wrong with it is that the rope around it is way too close to the end, so it would easily roll off the top without too much force needed on that. So it should be way down the base. And the other thing that they've used rope rather than tape. As mentioned before, rope is more likely to roll than a flat-sided tape. But the key thing here is that it's too high up on the bollard and needs to be way down at the base. The next piece of place protection we're looking at are wires, also called nuts. Now, the key thing with wires are that they are placed in a crack that tapers from wide to narrow. It must be, the more metal we can get on contact with the rock, the better. So the more metal of the nut or wire onto the rock, the better. So therefore, the bigger wires are generally better than the smaller ones. Here you can see this wire is placed in a crack that has a taper, so it goes from wide here down to narrow, down to there, and this wide bit here is where they put the nut in and then slotted it into that constriction. You also see that it's got a lot of contact, so a lot of metal touching the rock on this side and same on this side. You'll also notice that the wire is curved, and that just gives you more flexibility, more options of trying it. So try it this way around, try it the other way around, just to see which way it fits better with the curvature of the rock. Like most place protection anchors, the bigger the wire, the bigger the piece is that you get into a crack, the better, because you've just got more surface area of the metal touching the rock than you do with a smaller one. Wires can also be used on their side. Now this just gives you more flexibility, more options with different placements. And the key thing here is that you don't get quite as much metal touching the rock as you do when it's placed on the other way around. But you can use it like this as an option as well. So your wires will be on usually split into 2 or 3 different beaners, and you have between 5 and 7 wires on one beaner, all similar sizing, small, medium, and large. So once you've got the right wire for the constricted crack, leave the wire in there, and you leave the carabiner in that wire, and hold on to the other bunch of wires that you're not using, and give it a good firm couple of tugs so that the wire is nicely seated into the constriction, and then it's not going to pop out easily, but not, you don't jump on it, so it's so firm that you can't get it out again, but just a couple of nice firm tugs to seat it. The next piece of place protection we're looking at is a hex. Now, hexes aren't as common as they used to be, but still quite useful, especially in larger sizes when if you're a bit short on cams. Generally used in parallel cracks, and much like with a wire, you're trying to maximize metal on the rock here. You'll see that they have 6 sides, 1, 2, 3, 4, 5, 6 being a hex, and you can use them in 2 different orientations. So you can use it on this side, large side there, the small side, or you could flip it around and use it on this side and this side here. It just depends a little bit on what the nature of the crack you're trying to put it into. Now with the set like that, when its force comes down here onto it, it tries to twist the hex and creates a camming action which locks the hex in place in the rock. The hex can also be used front on, and that's more in a constricted crack, much like a wire. And one of the issues here is that you don't have a lot of metal because there's a big hole sitting in here. Next type of place protection looking at is cams, also known as spring-loaded cam devices, cams for short. Cams are for parallel-sided cracks as opposed to wires which are for tapered cracks. So you're looking for parallel parts of a crack. You want to make sure that the cam range is touching in the middle. We'll look more at that soon. And to prevent a cam walking backwards, you want to try avoid putting in a parallel part of a crack where further back you go, it widens up because cams can walk. Cams are generally easier and quicker to place than wires. You pull the trigger of the cam, so you're tracting the lobes. These are the lobes here, and retract them and insert them into a parallel part of a crack, and then release the trigger. And where you're aiming for is where this, like this cam here, is where the mid part of the lobes, all 4 lobes, are touching the rock. You want to avoid touching it here, which means that it's undercammed, or if it's touching up in here, it's overcammed. An undercammed cam means you're more likely to fail once it's weighted. Overcammed means it's unlikely to fail, but unlikely to crack the cam out afterwards. So you're looking for a parallel-sided crack, and how the cam works is once you've retracted the lobes and kind of hit on that midpoint of the cams here, touching on the rock, then when it's weighted, so when the force comes on down here, the cams try and push out, and they push out against the rock, which stops it from coming out. So cams can be placed mostly in vertical cracks, but also in horizontal breaks here, especially when the stem here of the cam is wire or flexible. Cams can also be used in pockets, parallel part of a pocket. It's a good place for cams if there's no other options. So here's an example of an overcammed cam. So you can see it's touching right on the very tips of the cams here, not in the mid-range where it should be here. So it's unlikely to fail, but you're unlikely to get this cam out, and it's a pretty expensive mistake to make.